The Higgs Boson particle, or the God particle, was discovered in 2012. It is and will continue to be considered as one of the most important discoveries in the world of physics. This discovery allowed scientists to have a closer understanding of the advanced field of quantum physics and to also begin answering the question as to why particles have mass. It was discovered by the Cern on the outskirts of Geneva, Switzerland. Their science experiments are nothing short of breathtakingly amazing. Welcome, dear viewers. Today we will take a look inside Cern's impressive projects, such as the Large Hadron Collider. If you're new to the channel, please subscribe to Futurephile to watch more fascinating videos on futuristic tech. Cern, or the European Organization for Nuclear Research in its French abbreviation, is a European research organization that operates some of the largest ongoing science experiments in the world. It was established in 1954 outside the city of Geneva and has personnel from a total of 23 states working together. While Cern's facilities cover all disciplines of science, their specialties lie in physics, namely nuclear and particle physics, as Cern's main function in this regard is to provide particle accelerators and other infrastructure needed for advanced physics research. The hub of international physics research is based there. A byproduct of such a gathering of scientists also led to the birth of the Internet itself. Indeed, the World Wide Web began as a Cern project in early 1989, led by Tim Berners-Lee and Robert Cailliau. The first website was uploaded and activated in 1991, and after 2 years of further development, Cern decided to make the World Wide Web free for use to anyone and everyone. Work in computing research still continues as grid computing is being developed there. Grid computing is a new method of computer operation in which multiple computers combine their power to perform on a single task together. But going back to the main topic at hand, the Large Hadron Collider is the largest machine in the world, and it is used by Cern. It is the world's highest energy particle collider, a machine that makes two particle beams collide to output energy. It took 10 years to build, with the focus of over 10,000 scientists across hundreds of universities and laboratories. The structure itself is a tunnel 27 kilometers in circumference and with a depth of 175 meters. Collisions started in 2010, and since then, it frequently pushed world records for the highest speed and highest energy particle collisions. Primarily, the LHC collides proton beams, but it can also beam heavy ions and proton-ion collisions. The intent of these collision experiments is to test, prove, disprove, and formulate various theories of particle physics. The discovery of the Higgs Boson particle in 2012, as mentioned before, was Cern's most important discovery. Made just 2 years after the beginning of operations, it allowed scientists to uncover a treasure trove of previously unknown information about the particle. A shutdown in 2013 due to operating troubles was followed by a restart in April 2015. Since that restart, physicists at Cern have been very hard at work analyzing and simplifying the hundreds of terabytes of data acquired from countless collision experiments in the collider. After extremely focused analysis and deliberation of the resultant deliberation, Cern announced that a new type of subatomic particle had been discovered, the Pentaquark. You see, a quark is defined as an elementary particle and thus the most fundamental constituent of matter. Multiple quarks combine to form hadrons. Examples of hadrons include protons and neutrons, which in turn compose atoms. A pentaquark is thus a subatomic particle that consists of 4 quarks and 1 antiquark bound together. An antiquark is a negatively charged opposite to a quark, and they exist in every quark cluster. Such a quark combination is very uncommon, and its discovery means that scientists could get to the root of current scientific theories, which suggest that huge stars often produce antiquarks when they collapse and disintegrate. If studies on the nature of pentaquarks is continued, then we may have a closer understanding of the physics of many types of stars in the universe, including neutron stars. Cern's Large Hadron Collider continued to make new discoveries as recently as 2020. Cern announced that they had discovered yet another new type of subatomic particle, the tetraquark. Physicists today still echo the opinions of physicists of the past, in that they could not believe that so many different types of elementary particles could exist in the universe. When the Higgs Boson particle was first discovered back in 2012, some of the questions about the universe that it answered only led to more questions. Answering questions about the fundamental workings of nature tends to lead to new discoveries and questions. These recent discoveries seem to suggest to scientists that there is nothing special about the Earth and even the Milky Way galaxy. They even go so far as to suggest that the current manner in which the universe is structured is also temporary. The fact that the science at Cern is difficult to explain in simple terms is exactly why the science being discovered there is so amazing and spectacular. Cern has no plans to stymie or stunt their pursuit of further knowledge about the fundamental blocks of the universe, so they have some ideas. One of these ideas include an even larger particle collider. They have recently taken major steps towards building a 100-kilometer circular supercollider to take the study of high-energy physics to the next level. Endorsed unanimously by the Serb Council, they have already begun seeking international aid for this project, as development is expected to cost at least $24 billion. To compare, CERN's annual budget for 2016 was $1.3 million. To be hosted near the already existing Large Hadron Collider, this new supercollider will take an even more detailed look at the Higgs Boson particle and raise the collision energies of proton-proton collisions to unprecedented levels. The supercollider structure would be rebuilt later in the century to be replaced by a proton-proton smasher, which would make collisions happen at energies of 100 tera-electron volts. By comparison, the Larger Hadron Collider currently collides particles at 14 tera-electron volts. However, not all scientists are optimistic across the board. Even when the Large Hadron Collider was first being built back in 1998, many scientists expressed concerns regarding micro-black holes. These micro-black holes could exist if a collision reached a high enough energy. With a new supercollider, such concerns are surely to resurface into the limelight. Scientists from Cern continue to assure us that the energy of the collisions is currently far too low to create even a small micro-black hole. They insist that even if one is created, it would have little energy to affect matter and will dissipate due to Hawking radiation, which is emitted by them. Questions about the possibility of strangulates being produced inside the collision chambers were also raised. Strangulates are small fragments of hypothetical form of quark. What would make strangulet formation dangerous is that they could possibly create a nuclear fusion reaction without the control of the physicists on board, potentially leading to a huge nuclear explosion. Cern retorted by saying that with higher collision energies, the possibilities of stranglet creation decreases. The Larger Hadron Collider is already less likely to produce stranglets compared to previous particle collider programs, which operated at lower collision energies. In Cern's new, more powerful supercollider, the chances of a stranglet being formed can reasonably be said to be non-existent. The importance of Cern to advancement in the sciences cannot be overstated. Curiosity is deeply ingrained in fundamental human nature, and Cern always seeks to push the boundary of what human curiosity can bring about. School students learning physics are all taught that visible matter in the universe is composed of a small number of particles. This understanding was made possible by Cern's efforts. We briefly mentioned Cern's development in grid computing, in which multiple computers or supercomputers can work together on a single computing task. Grid computing methods were developed primarily in order to process and compute the vast amount of data produced by experiments from the Large Hadron Collider. Thus, advances in computer technology made available to the public may easily be sourced from here. Some of the basic tools developed by Cern, such as particle accelerators and detectors, are frequently used in daily life. They were obviously invented to serve as tools of research, and now particle accelerators find practical applications in fields ranging from medical technology and computer chip manufacturing. Development of detector technology is also being expedited to allow PET and MRI imaging techniques to be delivered by a single device. Cern's main contributions to humankind and life on Earth will rest on their new supercollider, as this new Supercollider will make particles collide with each other at energies of 100 tera electron volts. The Large Hadron Collider is already a significant step ahead in us having a detailed study of the very building blocks of the universe. CERN's new Supercollider will allow even greater detailed studies, and no one can reliably predict what new things may be discovered. What is undeniable, though, is that CERN is an important part of global scientific efforts and will continue to be such. Let us know in the comments below what you think. Are you optimistic about CERN's prospects for substantial future discoveries? Or do you think CERN should start playing the game even safer? Or do you think CERN should focus their energies into other sciences? If you like this video, you may also enjoy our full playlist on inspiring future technologies that is shown in the end screen. And please subscribe to Futurephile to watch more fascinating videos on futuristic tech.